In this video, I would like for us to compute the definite integral from 0 to 1 of the natural log of x raised to the 1,000th power. Let me just mention that this is an improper integral because natural log of x is not defined when x equals 0. It has a vertical asymptote there. So if I wanted to be really correct, I would say that this is the limit as t approaches 0 from the right, and then I would have integral of t to 1, but I'm not going to switch into that notation, so I'll stick with this notation. How can we integrate this? My mind first goes to u sub when I'm stuck. So is it u sub? No, it's not u sub. The next place I go is integration by parts. Integration by parts is actually really useful in just a variety of contexts, actually. This is just kind of a toy exercise, but it turns out that integration by parts is the right notion here. So for integration by parts, I would like to identify a u and a dv in my integrand, where u is something that I would like to differentiate and dv is something I can anti-differentiate. I said, let your mind go to integration by parts as a general principle, but in particular, when you have an integrand that involves natural log of x, that's often a good choice for you in your integration by parts construction. Okay, so we will let natural log of x to the 1,000th power be our expression u. You might think there's nothing left, but there is. Dx, so 1 dx will be dv. Okay, so it's just u dv, literally. Let me write out du and v. Okay, so u is natural log of x to the 1,000th power. Please be careful here. This is not natural log of x to the 1,000th. If it were, you could pull the 1,000th down in front. So sometimes I've seen students inappropriately handle this kind of exponent. That's not what's going on here. The exponentiation is happening outside of the natural log function. Okay, so u is this expression. Du is going to be power rule, chain rule. So we've got 1,000 natural log of x to the 999 times the derivative of natural log of x, that's 1 over x. So let me write all of this over x dx. All right, so that's u and du. I'll write it. There's not too much to say about the other piece. So dv is just dx, or if you like, it's 1 dx, which means we'll let v be x. Okay. Now that we've broken this integral up into pieces with integration by parts, let's apply the integration by parts method. So u and v together, I'll write this as x times natural log of x raised to the 1,000th power. There we go. And then we will evaluate that at 0 and 1, where we have to be careful at 0 because natural log of 0 is not defined. Then we will have minus the integral from 0 to 1 of this product. Well, notice the x's are going to cancel. So x times 1 over x will cancel. Let me pull out the 1,000 as well, leaving us with just natural log of x to the 999 dx. Great, this looks really great. So let's keep going. If I plug in 1, x equals 1, natural log of 1 is 0. 0 raised to the 1,000th power is 0. So overall, 1 times 0. The other one, I'm going to state the result, and then I will prove it for you after we're done with this computation. So the heart of this is doing this integral, but we should establish that if x times natural log of x is going to 0, if x is going to 0, x times natural log of x will go to 0, as will x times natural log of x raised to the 1,000th power. This is something that we have to establish because this product is an indeterminate form as x approaches 0 from the right. So this is going to 0, but natural log of x is going to negative infinity. So natural log of x to the 1,000th power is going to positive infinity. So this is something that we should work out with, say, L'Hopital's rule. And then minus 1,000, integral from 0 to 1, natural log of x to the 999th power. Okay, we have 0 minus 0 minus 1,000 times the definite integral from 0 to 1 of natural log of x to the 999th power, which looks almost exactly like what we started with, except instead of raising natural log to the 1,000th power, I'm raising it to the 999. So what would this look like if we did another round of integration by parts here? If we did, we would let u be the natural log of x raised to the 999. dv would be dx. We'd end up with the same kind of computation here. It's just the power is different. Same kind of product analysis here. Where would we land? Okay, well, negative 1,000 stays out front. And then we would have, following the pattern 1,000, 1,000. The negative came out of this part of integration by parts. That would happen again. So we would have negative 999 times the integral from 0 to 1 of natural log of x to the 998. What if we did it again by using integration by parts here? We would have negative 1,000 times negative 999 times negative 998, the definite integral from 0 to 1 of natural log of x to the 997. Now, I'm not going to write this over 900 times. Instead, let's realize that if we kept doing it all the way down to, say, having 0 power here, so what if I wanted to keep peeling off these exponents until we were raising natural log of x to the 0th power? That would mean that the most recent coefficient that I would write out front here would be negative 1. So we would have like negative 1,000 times negative 999. We keep going till we get to negative 2, negative 1, which means I must now be looking at the definite integral from 0 to 1 of natural log of x to the 0th dx. Okay, let's pause for a second. Put this in the nicest form you can. All right, let's start by factoring negative 1 out of all of these coefficients here. So we have a negative 1 for each coefficient. There are 1,000 coefficients. So I will start by writing this as negative 1 to the 1,000th power, leaving us with a product of positive terms, 1,000 times 998 times, I skipped 999, but times 999 times 998 times 997. There's a word for that, is factorial. So 1,000 factorial. The natural log of x to the 0th power is just 1. The integral from 0 to 1 of 1 dx is 1. There's 1 unit of area under that curve. So at this point, we're done. You might have written just 1,000 factorial, and that's correct. But I like leaving this term out here because it highlights the general pattern. So if I said to you, what is the definite integral from 0 to 1 of natural log of x to the 5,007th power? You would know that the leading term would be negative 1 to the 5,007. That's odd. So it'd be negative 1 times 5,007 factorial. Okay, so we have this alternating term sign and then a factorial. That gives us a nice general expression for this integral. Just kind of a fun exercise. We are done with the heart of this problem, but just to be really complete, let me step aside for a moment and then come back and justify that I was correct when I wrote a 0 here, because if I wasn't, then the whole argument is wrong. All right, let's justify that part of the computation. And what we're about to do has some very similar themes. So what we really should have done in detail was take the limit as x approaches 0 from the right of the product x natural log of x raised to the 1,000th power. This is going to 0. Overall, this is going to infinity. When you have that kind of indeterminate form, where you have 0 times an infinite behavior, what you want to do is flip 1 to the denominator. Let's flip x, because that's kind of simpler. So let's write this as natural log of x to the 1,000th power all over 1 over x. Same thing. All right, now this is going to infinity, infinity. This is the kind of indeterminate form where we can now apply L'Hopital's rule. So we'll say that with L'Hopital's rule, this limit should be the same as the limit of the expression as x goes to 0 from the right of the ratio of the derivative of this to the derivative of that. So differentiate the top. We've done this before. It's going to be 1,000 natural log of x to the 999 times 1 over x. Differentiate the bottom. That's x to the negative 1, so that's negative x to the negative 2. -1 over x squared. We could multiply the top and bottom by x squared. So that we could rewrite this as the limit as x goes to 0 from the right of -1000. This cancels out now, leaving us with just x here, x, natural log of x to the 999. That should look really familiar. It's almost exactly what we started with. I've got this 1000 here. The power went down. So if I did it again, we would have limit as x goes to 0 from the right of -1000 times -999 times x natural log of x to the 998. So you can check that. If you don't believe me, do another round of L'Hopital's here, where first you need to flip to the denominator. So what if we kept going all the way down to having power 0? I'll do this kind of quickly because it mirrors the computation that we just did with the integral. This is going to be the limit as x goes to 0 from the right of -1 to the 1000 times 1000 factorial times x, natural log of x to the 0. Okay, this is a massive number, but x is actually going to 0. This is now 1. So that overall, the only term here whose limit we need to assess as x goes to 0 is x itself. X is going to 0, so this product goes to 0. All right, so that wraps up this exercise. I hope you enjoyed doing this integral with me.